Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So, without any further ado, let's get started. Today we are going to look at another topic from compiler design, which is LL1 parsing first and follow determination. So let's read the question first. Consider the following grammar with terminal alphabet A, opening closing parenthesis plus star and a start symbol E, right? All these are terminals and E is the non-terminal. The production rules of the grammar are E goes to small a capital A or capital E in between parentheses, and A goes to plus E or star E or epsilon. We need to compute the first and follow sets for the non-terminals E and A. We also need to complete the LL1 parse table for the grammar. So for those of you who might not recognize all these terms, we'll cover much of that in this video itself, but still if you find some concepts a bit new, then I'll highly recommend checking out the complete playlist in the I button here. Okay, so we'll begin now. First we'll visit some of the prerequisites that are essential for this one. One, we should know that what are terminals and non-terminals. Non-terminals are those parts of the grammar which actually elongate from that specific expression, and terminals are those which are constants. Meaning of that literal is what it just says, like a constant number or any other hex code representation. Then we come to the definition of first of x, right? Here x is a non-terminal. First of x denotes the set of terminals that begin strings derived from x. This will include epsilon if x derives to empty, right? If any non-terminal is present in the grammar which derives to empty, then we can say that epsilon will be contained in the first of x. Then we come to the follow of x. These are the set of terminals that appear immediately to the right of x in some sentential form. Right, we need to include dollar for the end of input when x can appear at the end. So in some grammar rules you will find that x appears at the end, so for those we'll have to include dollar in the end. Now this is all theoretical explanation. Things will get clear as we do the actual problem solving. First we'll see how to compute the first and follow iteratively. We'll have to propagate until the sets stop changing. So you'll see that the first and follow sets will have to stop changing from iteration to iteration, and we can then say that we have arrived at a solution. Then we will see how to build an LL1 parse table from the first and follow sets. Right, this is what we will cover, and if you do find any of the words or topics I mentioned just now to be a bit unclear, then again check out the playlist which I have referred previously. Okay, so first we'll compute the first sets. So first of E, we'll take the first production rule, which is E goes to small a capital A. Here A comes first, so it will belong to the first set of E. Then from the next production rule, E goes to capital E in between parentheses. Here the first of E will contain the opening bracket. Then we can say that the first of E will contain A comma opening bracket as the set members. Then we will compute the first of A. So from the first rule, A goes to plus E, so plus will be in the first of A. Then A goes to star E, so star will be in the first of A. As well we have A goes to epsilon, meaning epsilon will also belong to the first of A. This is straightforward computation. No further propagation is needed right now. Now we'll complete the follow sets. So we'll start with a symbol E, which always has dollar in its follow set, right? We'll find the occurrences of non-terminals on the RHS first. So E goes to small a capital A. Here A is at the end, right? So follow of A will be the subset of follow of E, right, as per the theory discussed above. Then we see the next rule where E goes to capital E in parenthesis. So E is followed by a terminal, right? Therefore terminal closing bracket will be belonging to follow of E, right? Then we say A goes to plus E and A goes to star E. Therefore, E is at the end of RHS, meaning that follow of E would be a subset of follow of A. Now we already get a big understanding from these two, right? Now we can see that we have mutual dependence. Follow of A is a subset of follow of E, and follow of E is a subset of closing parenthesis $sign union follow of A, right, as per our discussion from here. Now if we solve these two, because by observation we can say that we can come down to a proposition where follow of A equals follow of E, then we can say that if we add both closing parenthesis and $sign on both sides, equality is maintained. Then using the above expression we can say that it will be equal to follow of E equals follow of E plus closing parenthesis and $sign. Here plus sign is actually representing a union operation. So we can say that follow of E equals closing bracket and $sign, which will ultimately be equal to follow of A, where closing sign and $sign are included. Now if we put these two in the above expression, these are completely satisfied, right? Hence our proposition is actually correct. Alright, now let's try to build the LL1 parse table. So the rule for creating the parse table is simple. For x to alpha, where alpha is a terminal and x is not, place the production in m of x comma t, right? For each t first of alpha, set minus epsilon, meaning we are taking all those t's which belong to first of alpha except epsilon. Now if epsilon belongs to first of alpha, place x goes to alpha in mxb for every b belonging to the follow of x, right? Now this will become clear once we actually start building the table. So we'll first compute the first of all RHS values, right? So a first will go to small a only. For E it will be opening bracket, for plus E it will be plus, for star E it will be star, and epsilon first contains epsilon, as we know. Now we'll come across the table rows for non-terminals E and A and columns as terminals, right? So this is the table, right? So now let's revert back to the rules. The rule says for x to alpha, place it in the production of x to t for each t belonging to first of alpha, right? So the row is fixed, it will be in the E section. So let's take the first one, E goes to AA, and let's try to figure out ourselves where this should be, right? Obviously it will be in the row of E, and now the first of alpha, right? The first of alpha here is A, so it will be placed in the column of A, right? Now let's visit the next one, which is E goes to E in parenthesis. So for that as well, if we look at, the row is going to be of E, and for the column we'll have the first of this expression, which is opening bracket. Hence it will be placed in this particular cell. Now let's have a look at A goes to plus E. So for that we'll have plus E in the column of plus, and it will be in the row of A. So here it will be placed, right? Next, for A to star E, again the thing stays the same. The column will be star and the row will be that of A. So it is present here. Okay, so we have done these two. Now the remaining pieces are this one and this one, right? Now let's try to figure how to put that, because we have another production A to epsilon, right? So for that we have the second part of the rule, which says if epsilon belongs to alpha, place x to alpha in mxb for every b belonging to follow of x, right? In our case, follow of A is closing parenthesis and $sign, right? So in both these we'll have to place A to epsilon, right, which we are doing here. Remember that after putting all the terminals in the heading section, we'll also have to put $sign, right? So in this way we can see that there are no conflicts in the LL1 table for the grammar is without conflicts, right? If there had been more than two expressions in one particular cell, then we can say that the grammar is ambiguous, hence not appropriate. So the inference is the grammar is LL1 predictive. First sets for alternative productions of the same non-terminal are disjoint, which is ensuring that the grammar is unambiguous, and epsilon productions are handled via follow sets with no collisions. Other modifications which you can find in these sort of problems is adding conventional precedence and associativity, making operations right associative, and reporting errors and recovery methods, right? All these modifications as well as other similar questions are actually discussed inside Sigma Solver community. So if you do want to get access to those or even the notes in this lecture or elsewhere, you can do so by joining the community, which is by clicking the link in the description below. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.